Again, so good morning and welcome to Data Migration Enabled by Conduit. My name is Claudio Barbura, a Principal Development Manager at Blueprint Technologies, and I work with a team on Conduit. We're at the 1.2 release. We're in a marketplace, in the Azure marketplace, but we can also deploy on-premise. And in a nutshell, what Conduit is a secure and lightweight data virtualization tool. And I'll elaborate what we mean by that and how it helps with data migration today, and what are the plans we have to support data migration in the near future. So I'll present you a few slides and talk about what Conduit is, and then we'll quickly do a demo to demonstrate really how Conduit can help you in a data migration scenario. So Conduit, think of it as this lightweight tool that deploys anywhere on premise in the cloud and does not have too many dependencies. That's why we're lightweight. And it connects to any data source. And you see a list of the supported data sources today on the left, from Postgres to Azure Blob Storage to Elasticsearch, anything across open source or managed cloud services. And this list is being developed and continues, and it's prioritized by customer demand. So Conduit connects to all these data sources, and it also enables various consumers like BI tools like Power BI or Tableau, or custom applications to access these data sources in real time through unified data protocols, either, as you see here in the box, JDBC, ODBC Thrift, or OData. And so that's what makes us a data hub. And the secure part comes in the fact that we do support authentication, various forms of authentication and authorization, including Active Directory, Azure Active Directory, and Active Directory Federation Services, basically on-prem or in the cloud Active Directory. So we enable these users from these consumer applications or reporting tools to use their AD credentials, even against sources that they don't support that. Like think of Elasticsearch or Azure PostgreSQL. They don't support that today. But if our users using Conduit, can still be enabled for Active Directory. So this is really important part of our key value proposition. So secure data hub for real-time access to these data sources. And the virtualization piece comes in the fact that from these tools, you can access and join basically any of these data sources, any data entity, whether it's an OData service entity with an Elasticsearch index or some file in or folder of files in blob storage. You can join them in your tool of choice or consumer custom application built over the Conduit APIs, as if they were just SQL tables. And that's how you see now Conduit speaks Spark SQL. We are a Spark SQL server for Power BI, and we basically expose the same interface, the JDBC ODBC Thrift. Or we also have an OData endpoint for applications that want to build against the REST interface using standard data protocols like OData. So Conduit takes Spark SQL in, and then it goes and generates native queries against the external systems. Or when we cannot convert to native queries, think of a count distinct, for example, is not supported by OData services or Elasticsearch. In that case, we cannot natively translate it. And then we have to use a SQL engine like Spark to still be able to honor that particular query. Or think of custom aggregation functions like standard deviation and so on. There's many functions that users like to use in their BI tools of choice that Conduit will honor. Will really serve 100% of the queries sent by these tools. And then we also use Spark for hybrid joins. If we need to, as you see in the example, join a table, Postgres table on premise with one in the cloud, in the managed service provided by Azure, with some files in Azure Blob Storage or Elastic. Any combination of data sources can be supported. That's what we call this a hybrid join. So quickly, the list of features, we have these connectors. We're at our 1.20 release. We have these 8 connectors, and that list is growing. We are a security bulkhead. We support that central authentication authorization. Basically, for all these sources, authorization access rights rules can be defined in Conduit. Instead of defining authorization rules in each of the data sources externally and maintaining that, an organization that uses Conduit can just define those rules centrally in Conduit, because that's what the authentication happens as well, the integration with Active Directory. So it makes sense to extend that to authorization. The protocol that we support for the BI tools, Power BI, Tableau, or even Spark, distribution of Spark, they can use our JDBC ODBC Thrift interface, but we also support OData with aggregation extensions about all these data sources, right? And this is an important part, the aggregation extensions. It's all about aggregations in these BI tools. And in the lightweight virtualization, part of our core value prop, we use Spark for non-native query translation. As I mentioned earlier, we are an optimistic caching layer. It's policy-driven. This offloads computation resources from the data source to Conduit, and it allows critical transactional systems to not be competed for by reporting or any read operation basically coming from BI tools or custom applications. And then the hybrid join story that I just talked about earlier. So now, how could Conduit actually help in a data migration scenario? And I'll give you a quick example. Imagine you have data on premise, and I just pick one database. It's a PostgreSQL database on premise, and for example, there's also data in some blob storage, Azure Blob Storage, and Parquet format, because the data engineering team has built some data pipelines, and they push that data into Parquet or JSON format or CSV for that matter in blob storage, right? They're just sitting there. There's no basic schema associated with them, but it's the same data that's in the Postgres database. And now throw in a Elasticsearch index that's hosted on a VM in AWS. So let's imagine that the organization wants to basically migrate all that data from all these sources into a managed service, Azure Postgres, because of many reasons, reliability, high SLAs, scalability of their Postgres databases, cost savings. There's many reasons for why a company wants to migrate to the cloud. I'm just giving an example. So this migration can be expensive and time consuming. And at all times, there are consumer applications connected to the data sources. So the challenge for the organization, for the AT, is to still provide that SLA for their users through their applications while the migration is happening. So this can happen gradually if you use a tool like Conduit, where these applications are, instead of talking directly to these data sources, they're talking to them through Conduit, right? So Conduit will basically abstract and shield the migration details to these applications. Instead of the application being aware of a change of physical location of these data entities that they're consuming from on-prem to Azure and having to deal with that switch, they will always just talk to Conduit, as you see in the demos. And then that allows the organization to perform the data migration at their own pace, on their own schedule, and just really change these settings, the source of the data connected to Conduit when the migration is complete, and the front-end application and the user will never notice. And then I'll come back later to the features that we're building right now for the next release 1.3 that also help with the in the migration scenario. So for now, I'll switch to the demo. So we're going. I'm going to show the management console first. So this is the content management console where you come in and you set up these connectors, right? We have the 8 data sources here: Azure, OData, DB2, Elastic, Dynamics 365, Azure Blob Storage, Postgres, and Maria. And these are both on-prem and the managed Azure Postgres services. So I'll show you how I created 3 connectors. First one is Postgres Azure, connected to that cloud URL. We're saying we want Active Directory with impersonation. Basically, we want the users to be authenticated with their Active Directory credentials, excuse me, in one particular Active Directory subscription because multiple are supported. In this case, we're using our own Blueprint BPCS subscription. And then Conduit will use a service account to connect to the Postgres database. They do not support Active Directory yet. If this was a source like Azure SQL, we would be able to also have a pass-through scenario where we pass through the AD credential from the user straight down to the data source. So we also support that. For Azure SQL and Dynamics, we do support that. And then we want to enable authorization and access rights for this. We want to cache queries for join queries. We want to be able to cache those so that we obviously improve the performance of the reports. And in this case, we're going to choose a local Spark cluster to perform the join queries, right? And what's coming, I want to show you quickly. What's coming in the next release is the ability to attach to external clusters, either Databricks and HD Insight for now, to perform all these join queries. So for now, we're using the Spark deployed on the same instance as Conduit. We're using the same cores and memory and that local basically Spark in quotes cluster is just one node to perform all non-native queries and the join operations. But in the future, we want to be able to basically execute all our queries on an attached external cluster and use their compute resources and the memory and disks for caching. So back to the connectors, I created the Azure Postgres, decided to publish a few data sets for the consumers. And one of them is books. Now you can see the schema. There is book number, title, author, a lot of information that people want to report on. And really, there's some advanced settings here for caching, for expiration, for distributed loading over that source. And at the end, really, there's the Conduit endpoint, either the JDBC or the Power BI/Tableau Spark Connector endpoint. And that's what we copy as an admin and we email out to our users. And this is the unique Conduit URL that will allow users to consume all these data sources, right? This is the secure HTTPS URL. And we're basically using Postgres Azure. We also show an on-prem connector. Let me filter by type here. Postgres. This is an on-premise Postgres SQL database. We're going to use the same authentication method, even though it could be ADFS instead of Azure AD. And that's also supported. Similar settings. We will also publish the books. That's what I care about, because we're assuming that this is the data set we're migrating, the books data set, right? And it could be the same data, could be different data, partial data is being moved, so on, and the same URLs. And also, I want to share the Azure Blob Storage connector that allows us to maybe there's files with the same data schema, different data but the same schema, books. In Azure Blob Storage, that we also want to move that now to the cloud. And in the in the meantime, we want to allow consumers to query that data regardless of the migration status. So that books is coming from a storage account, Conduit storage, some container as an access key. This is basically the URL for Azure Blob Storage. Same, we're fronting AD here for the users. We pick Parquet as the type of file supported. And you can see here, this is just browsing all the folders in that container, and we're picking this folder, which are now Parquet files compressed, very likely written through a Spark job by a data engineering team. What Conduit does, it will infer the schema and will make those files look like a SQL table when we're exposed to the user, right? So we're picking that URL. I'm not going to say on the authorization piece, access rights that you can enable on these settings too much. I'll just show that at BPCS, I'm part of the developers group. So now that I have the developers group, I can define access rights across all connectors, all data sources. And I just gave myself now permissions to all these so I can access these data sources from an external tool like Power BI. So now I'm going to go to Power BI. And as a consumer, the first time I'm going to any tool, I will look for Spark. It's the Spark connector. That's what Conduit is. And once I find a Spark connector, I'll say connect, and I'll paste in the URL that was emailed to me by the admin. And right, I'll pick HTTP, the protocol, and I'm doing direct query. It's all about real time with Conduit. There's no importing. There's no importing of data in my Power BI desktop. I want to be able to have access to the data source and always have the most up-to-date data. So as you see here, now Power BI is browsing that URL and is displaying all the data, all the entities across all those 8 connector types. Some of them are the one that I look for, file, books, Parquet, right? If I see it, I just see it as a SQL table. Now, even though there's some files in some format on blob storage, Conduit, and for the schema, I can see the book number, book type, book author, so on. And I can also load my Postgres, OnPrem books, it's here, and the Postgres Azure books, right? So these are already loaded in my canvas. And I can really access them just if they were just SQL tables, right? So in this case, I want to show how I'm accessing that data. So I have the book number from the Parquet files, basically in blob storage, and I'm going to aggregate that. I'm going to use the book author dimension here from public books, right? Which is my Postgres database in Azure. Whatever partial data I already received, I'm going to join that. So because I'm using different fields from different data sources, Power BI will attempt to run a query across the 2 tables. What I also did, I also established a relationship between the 2, right? I said, I want these file books Parquet here is related to my my Postgres table on that unique book number, right? So this is what I had to do to come into basically Power BI and establish this relationship in my canvas. And now I determined the cardinality is 1-to-1. You can do both in cross-filter direction. I said, okay. And from now on, any queries I run, and I include fields from the 2, Power BI will run a join query, right? Because these 2 are related. So the join query comes to Conduit, and now Conduit, you can see the query in our Spark console, just to show what it looks like. Right? It's this query here. That what's important here that it's a left outer join between a Postgres public books, right? That's my data set in Postgres on the book number, right? With the basically it's the join between the, no, this is MariaDB with Postgres. Let me actually trigger the join between the flat storage, flat file books, and let's see which one is what. So it's file books with Maria, and then this one is books with Postgres. Okay, so this is the one that I wanted to see. So I'm clicking here, so this will trigger a query. We'll filter by this author name. I should see the query running here now. Okay, so it's the join, left arrow join basically between Postgres and books parquet, right? So from here, this is the key part, right? So I was able to actually join these two data sets, completely different data sources from my Power BI canvas. So that's the virtualization piece. Now, obviously, you don't have to join unless you need to, but the point here is to make is that you can access these data sets through Conduit as if they were tables, right? And the migration can happen in the background. The team can just move data from one system to another one. Imagine if this is from Azure Postgres, from on-premise Postgres to the cloud, to the managed service in Azure. All they have to do is, once the migration is complete, basically the system admin has to go back to the connector and change the URL and point from on-premise to point to the data entities in the cloud, to the Azure managed service, and the report will still work, right? So the users are shielded by that particular change. So this is just Conduit giving you access to these data sources as if they were just tables in the same repository. Obviously, allowing you to do the hybrid joins between them if necessary. And what I want to also show you is what else do we have currently in development to support migration, right? And I'll take you to the roadmap slide and talk about, now, in addition to the fact that we're adding more connectors, you see the AWS S3, DynamoDB, Cassandra, so on, Cosmos DB from Azure. In the virtualization space, now, I already mentioned, we want to be able to attach to an external cluster to basically use more compute and more memory, if somebody has it available, to run these non-native queries, what we cannot translate natively, and so we can also do the hybrid joins. And then we're targeting initially Azure Databricks and Azure HD Insight, but we're looking at SQL Server, Big Data Cluster, CDH, Pivotal, and so on, right? We should be able to support any Spark distribution out there, really. So we're just talking to the native Spark APIs. But there's two features here that I want to mention that are work in progress right now: virtual table and query federation. So what does that mean is if there's data across disparate sources, but there's a common schema between them, maybe the same schema, or just imagine a few select field, the common denominator between these schemas is the same, we can create you can create in Conduit a virtual table, which will have that common schema, and it will probably even do some mapping, field-to-field mapping from the source to this new virtual table schema. But this virtual table will know that it has to query as a large number of tables across multiple data sources, right? When you define a virtual table, you're pointing to all those data sources. And in this case, for our example, I want to say I'm going to create a virtual table and point it to Postgres on-prem, Postgres in the cloud, and Azure Blob Storage, right? Because I know there's common schema, they're all books. So I'm going to expose this now through our URL in the consumer books, And now every time a query is generated by the user from that Power BI mashup, we will federate that query to all data sources behind this virtual table, and we'll do a union basically of the results. So we'll support any aggregations, any filtering, any predicate pushdowns will be performed. But in the end, the user will get back the union of the results from the three sources, right? So that's how we federate the queries. And it doesn't have to be Power BI. It can be any consumer application that wants to connect to our JDBC API, right? Or OData for that matter. And so we support hybrid joins and then query federation. In 1.3, we'll have this new feature, query federation. And that allows you to query these systems while they're being migrated, right? So this is not Conduit doing any migration per se, but it's helping the applications pointed to those systems talk to a unique URL, to a unique set of table names. So they don't have to change when the migration is complete, right? Migration happens in the background. When it's complete, the system admin can just go to Conduit and repoint, basically, repoint, for example, this on-prem database, Postgres here, this connector. It can point it to the cloud URL and then recreate the same, publish with the same table names, recreate the access rights rules, and there you go. The applications will just talk to the new data that's already migrated. And back to the roadmap, what we also want to start doing is the actual data migration itself, where since we know the systems now, we have means to connect to them securely, right? We enable secure access to the data sources for the users, and we support all those authentication authorization rules. What we also want to do is, if in this scenario, right, Postgres to moving from on-prem to the cloud, if whether we want to use our local Spark or maybe attach to an external Spark that this organization has, Conduit can perform the migration itself, basically. It can move the data from one system to another one. It can create the schemas, and it can perform that really is going to be a Spark job. It's going to read from the source and write to the destination, basically. And we want to be able to show you, monitor that job, because it's very likely a time-consuming job. You'll see, Conduit has a monitoring console. It embeds, Grafana, and it has ELK for all the logs. All the connectors here have an already pre-created, let's see, the Postgres one that I just accessed, or the flat file. Let me pick it. Where is it? Books. Okay, I can find. I just pick one. Books here. So we have, for each connector, we created an automatically generated dashboard with latency, throughput, and a call count, just to show the overhead that Conduit adds. So the same, we will provide a monitoring console for those export jobs from the source to the destination, where basically Conduit will perform the data migration. So that's work in progress for us right now. And I'm really excited to see that now coming through very soon in the 1.3 release, actually. So if there are any questions, I'm ready to take them now. But that's basically that's the gist of how Conduit can help with data migrations for all the data sources that we support today. Okay, well, thank you for joining, and hopefully people that couldn't join will be able to download this. It's recording. We'll publish this webinar, so you can record it at a later time. and you'll hear more from us at Blueprint soon. Thank you.